No, no questions? Okay. So then next, okay, so that was this one. Next, we need to do the exponential decay assignment on page 42 and 43. So we're going to be graphing exponential decay today. So we're going to complete the table and then graph it on the back. So just like we did last week for exponential growth, we're just going to plug in the x value that they gave us and simplify. So we have 1/2 to the negative third power. And so let's see. How do we want to do this? What's the easiest way? Hmm. I don't know if I want to have you do this. Because we're going to get really small decimals. So since it's to the negative power, so we can do the reciprocal. So 1/2 to the negative third power. So to get rid of the negative exponent, we can just flip our fraction and then the exponent becomes positive. So instead of doing 1/2 to the negative third power, we can do 2/1, which is just 2 to the positive 3 power. So then 2 to the third power, 2 times 2 times 2 is 8. So our first point would be -3, 8. And then we have then we have 1/2 to the -2 power. So we're going to flip the fraction. And so 1/2 becomes 2, and then our exponent becomes positive. So 2 to the positive 2 power, that's 2 times 2, which is 4. So our point will be -2, 4. And then 1/2 to the -1 power. We flip the fraction, and that's just 2 to the positive 1 power, which is just 2. So our point would be -1, 2. Okay, go ahead and try to complete the rest of the table on your own. So just plug in the x value and then write your point. Oh, sorry. For those of you just joining us, we are on page 42. Oops. Okay, so can I get a volunteer? What did you get when x is 0? What's 1/2 to the 0 power? You can send it in the chat too if you want. Yes, thank you, Bella. Yes, anything to the 0 power is always 1. Doesn't matter what it is. So this point would be 0, 1. Thank you. Okay, and then 1/2 to the first power. Anything to the first power is just itself, so it's 1/2. And then 1/2 to the second power. So that's 1/2 times 1/2, which is 1/4. So this would be 2 and 1/4. And then we have 1/2 to the third power. So that's 1/2 times 1/2 times 1/2. Which is 1/2 times 2 is 4. 4 times 2 is 8. So remember, you just multiply across the top and then multiply across the bottom. So this last point would be 3 and 1/8. If you're just joining us, we're on page 42 in the algebra workbook. Okay, and then we have 2 to the negative x. So we're going to just substitute our x values in again and find what y would be. So 2 to the negative, be careful because x is a negative. So negative third power, which a -1 times -3 is just +3. So 2 to the third power, that's 2 times 2, which is 4. 4 times 2, which is 8. So this point is x is -3, y is +8. And then we have 2 to the -2 power. Negative times negative, it becomes positive. So 2 to the +2 power, 2 times 2 is 4. So it's -2, 4. 2 to the -1 power is just 2 to the +1 power, which is 2. All right, if you just joined us, we're on page 42 in the workbook. Okay, and by now, are you guys noticing a pattern between our two tables that we're completing? We got -3, 8, -3, 8, -2, 4, -2, 4, -1, 2, -1, 2. So it's safe to assume that the rest of the points are just going to be the same. So the purpose of this is to just show you that 1/2 to the x power is the same thing as 2 to the -x power. And let's see what our graph looks like when we have a growth multiplier of 1/2 or an exponent, a negative exponent. So on the next page, we'll sketch these points. So our first point was -3, 8. And -2, 4. -1, 2. 0, 1. Oh, this was supposed to be 1, 1/2, sorry. 1 and 1/2. 2 1/4. And 3 1/8. Okay, so as we can tell from the table, all of the points were the same. So if we graphed 1/2 to the x, it's the exact same of this graph that we already have. So what does this say about 1/2 to the x power and 2 to the negative x power? It means that they are the same. What? Okay, I'll have to do it when I'm done with this. Okay, so can we show that they are equal? Yeah, so if we have 1/2, we have 1/2 to the x power. So let's get rid of our negative exponent for 2 to the negative x. So to get rid of the negative x, we just take the reciprocal, right? So the reciprocal of 2, it's 2/1, right? So we would flip that and it would be 1/2. And then the negative exponent becomes a positive exponent. And if you look at the graph, you'll notice that it's now going down. That's why we call it decay, because our values are decreasing. So they were decreasing by 1/2. And so let's go ahead and switch over to our notebook, and we're going to take our notes on that same page that we wrote notes last week. So for me, it was on page 6. I'm not sure which one yours is, but your exponential function. So I'll give everyone a minute to go ahead and get those out.
Can you please move the paper down?
Like that?
Sorry, I meant up. Okay, thank you.
Yeah. Okay, so exponential decay. We know it's decay when the multiplier is less than 1. Just like we had 1/2 to the x. Sure, I don't know. So say we have something like f of x equals 24 times 1/2 to the x power. And this tells us that we are starting with 24. And then that it is decreasing by 1/2. So each time it's cutting in half. So then we can complete our table. So we're starting with 24. So when x is 0, y is 24. And then it's decreasing by half. So half of 24 would be 12. And then half of 12 is 6. And then half of 6 is 3. And then we'll go ahead and graph it. And we'll scale the y again by 4s. And then the x-axis just by 1s. So 0, 24. And we're just going to plot the points. 1, 12. 2, 6. And 3, 3. Okay, and so it sounds, the graphs look just like how they sound. So when it's exponential growth, it's going to grow. Your graph is going up. If it's exponential decay, when you think of decay, it's going down, and our graph goes down when it's exponential decay. So anytime you have a negative exponent or a fraction, that means your multiplier is less than 1, and so it's going to be exponential decay.
Sorry to interrupt, but do you mind if I can be excused? Because I have a meeting with my doctor in about 3 minutes.
Okay, sure, no problem.
All right, thank you.
Mm-hmm. Okay, so let's go ahead and work on the assignment. We're graphing exponential decay, so it's on page 44.
I wasn't done.
Okay, so I'll put it up for just a minute. If you want to take a screenshot, if you can copy the other notes down, maybe just take a screenshot really quick.
Okay.
Okay, you got it?
Yes.
Okay, so for exponential decay, we're going to want to create a table for each equation and then graph. So since we have more room for a vertical table, we'll do a vertical table. So we have our x, and then we need to find our y. So 0, 1, 2, 3, 4. So when x is 0, we know that y is 18. That's just our initial value. For all of them, we always know that it's going to be this number because that's always the initial value. Whatever value you're multiplying by, that is the initial value. And then we need to plug in 1 for x, so that equals 18 times 1/2 to the first power. Do we really have to do that for each one? We know that we're just cutting it in half. So rather than doing all that work, we'll just say, what's half of 18? Well, that would be 9. And then what's half of 9? So each time we just divide by 2, just like we said in our double bubble, we're either multiplying or dividing. When it comes to exponential decay, we're going to be dividing each time. So we'll divide 9 by 2, which is 4.5. And then we'll divide 4.5 by 2, which is 2.25. And then divide 2.25 by 2, which is 1.125. And so we'll graph those points, 0, 18, 1, 9, 2, 4.5, 3, 2.25, and 4, 1.125.
Can you zoom in?
Sure. So it's just an estimate because they are decimals. So for 4.5, you just do it between the 4 and the 5. And then 2.25 just a little bit above the 2, and 1.125 just barely above the 1. Okay, so I want you guys each to try one. So go ahead and create your table. And for number 2, let's have Nathan, Tiana, Kaleni, and Bella. Go ahead and do number 2, and then Dakota, Solomon, Esmeralda, and Rebecca do number 3. And then Lenice, Milani, and Cheyenne do number 4. So go ahead and do your problem, and then we'll go over them together. And if you need help, feel free to send me a message in the chat and I can help you. And luckily they're all just 1/2. I kept it simple. So you're just going to be cutting them in half each time. So for all of them, you're going to want to go ahead and just start with the table that we had, just like number 1. And you can use 0, 1, 2, 3, and 4 again. Okay, I'll give you guys another minute just in case you're not done, and then we'll go ahead and go over them. Okay, can I get a volunteer from the first group that wants to tell me how you did number 12, what you got in your table and the points? So Nathan, Tiana, Kaleni, or Bella?
I'll go, I guess.
Okay, thanks, Bella.
So for the initial value, it's 0, 12.
Excellent.
And then I just cut it in half each time from
Perfect.
there. So
Yep.
I got 1, 6, 2, 3. And then I did fractions instead of decimals.
Oh, sure, you could do that.
And then I did 1.5. And then 3/4.
Yeah, okay, so I should write it in. 1.5 and 3/4. Yep, that works. So 0, 12, 1, 6, 2, 3, 3, and then 1.5, 1.5, and then 4 and 3/4. Very good. Thank you, Bella.
You're welcome.
Okay, moving on to number 3. Do you guys want me to zoom out so you can still see number 3 in case? Okay, or number 2 in case.
Okay.
You gonna do Dakota?
Yes.
Awesome. Okay.
Okay. So the first. Okay. Starts 0, 20,
Very good.
and then 0, 10,
Good.
and then it'd be a decimal, right?
Well, it would be just be half of 10. So what would happen?
Oh, 5.
Yep. And then half
And
of 5.
That'd be 2.5, or would it be 2?
That's
2.5.
right. Nope, 2.5.
And then half of that will be 1.5.
1.25. Good.
1, 2, okay.
Very good. Thank you, Dakota. And then we'll just plot the points. So 0, 20, 1, 10, 2, 5, 3, 2.5, and 4, 1.25.
Can you scoot it down?
Okay, I'll give you a second to copy. Yep, and we'll go over the last one.
Can you?
Do you mean
Can you?
down this way?
No, I have a question.
Oh.
Would it be possible to break it down even more if it was like if you're trying to get some more decimals, or the main one is just 4?
Yeah, it's gonna keep getting really, really, really small. So
Okay.
yeah, you can get down to like 0.0000000 blah, blah, blah. But there's no need to. I mean, you can't, it keeps going on forever to approach 0.
Okay, so 4 would just be
Yeah, we can leave off with 4. As long as we have a couple points, we can see what the graph looks like. That's all we need to do.
okay.
Say with your chest.
Okay, and then our last group.
I'll do it.
Okay, thanks, Milani.
No problem.
Okay, so what'd you put for y when x is 0?
8,
Good,
and then I put 4,
good,
2,
very good.
and the last one is a 0 or like 0.
What's half of 1?
0? No. Yeah, 0.5.
It would be, yep, 0.5. Good, half. Thank you. So then we'll just plot those points. So 0, 8, 1, 4, 2, 2, 3, 1, and 4, 1/2. And so it won't always be 1/2. This was just to get comfortable. So mainly what you might see is like 1/3, so or 1/4 or 1/5. And you would just divide or cut it by whatever number it is. So like if it was 1/3, it's decreasing by a third. So you would just divide by 3, kind of how you divide by 2 each time. And then if it was 1/4, you would divide by 4 each time to get the next value. If it was 5, if it was 1/5, you would divide by 5 each time. But for today, we just wanted to get the big idea of exponential decay, which you guys got. Very good. Okay, so we have like 10 more minutes. So we can go ahead and fill out the double bubble, comparing now exponential growth to exponential decay. So sorry, I know there's a lot of comparison in double bubbles. This is what the standards cover for exponential. So they just want you to understand the basics of exponential and then more so be able to compare them. There's a lot of comparison in the standards for this unit. So that's why there's a couple double bubbles. So let's compare exponential growth and exponential decay. So why don't you, I'm going to give you a second. Look at your notes. You can use the graph, use the table, talk about the initial value and the multipliers. Go ahead and see if you can fill in a couple things on the double bubble.
Because I have 1, 2, but did you want them?
Sorry, you were cutting out. Dakota, can you say it one more time?
I said- I said, I have one. Do I tell you?
Oh, hold on.
Okay.
Yeah, and then yes, I definitely want you to tell me in just a minute.
Okay.
Okay, so what do you guys have?
Okay, for one of them, here 1 second. I felt like it was the adding and then not the how would I say it? The one that goes different ways. One's going down, one's going up.
Yep. So we could say graph is going up for exponential growth. And we can sketch a picture, right? Going up. And then for decay, our graph is going down. Very good, Dakota. Thank you. Solomon, do you have one you could share?
He went to go get one of his papers.
Oh, okay. Cheyenne, do you have one you could share? No. Okay, so we just have to look at our notes. So we can see for exponential growth, the multiplier is greater than 1. So for exponential growth, we write multiplier is greater than 1 for exponential growth. For exponential decay, then, we're going to say the multiplier is less than 1. And if you don't have the notes, it's probably harder to do this. Then we could just write an example like f of x equals 3 times 2 to the x. That would be exponential growth. And then our exponential decay, which is f of x equals 24 times 1 to the x. Just give an example. What do they share? They still have a is their initial value, right? A still tells us the initial value for both. And then they still both have a b, which is a multiplier. So we could still say b is the multiplier. And then they're both exponential functions. So now you have your double bubble filled out. So now you just need to explain it in sentences and write a paragraph comparing exponential growth to exponential decay. Any questions about how to write your paragraph? Okay, so you guys are in good shape for the week. If we look at week 5, we finished section 2. We almost finished section 3. You'll have to do the unit 7 journal on exponential decay. And then you're almost done with the exponential growth versus exponential decay double bubble. You're finished with that. You just need to work on the paragraph. So you'll write your 2 paragraphs and then do your checkpoint, and you're done with Algebra 1 for the week.
Can you flip back to that page, please? I didn't finish the one.
So thank you all for coming. I know your teacher, Mr. Thomas, has been working really hard to get those of you in here. So I hope that you will continue to come and see that it is helpful. It's really helpful if you come each week. We get a lot done together. So I hope to see you all again next week. If you want to stay on, I still have office hours from 11 to 12 if you need help on assignments or up assignments. If not, the rest of you are free to go. Have a great week, and I'll see you next Wednesday.
Thank you so much.
Thanks, Bella.
Thank you.
Thank you.
Thank you, guys.
Thank you.
Oh yeah.
Yeah.